Hello everyone. Today we are going to discuss about scattering of light. Scattering of light. This is the chapter from human eye. This is the topic related to the human eye, and it's the second part of the optics. Hope you will understand it. Before discussing about the light, I want to ask my dear students that do you know what is light? What is light? We have got idea related to light in class 6, class 7 and class 8, also in class 10th, as well as you will get the idea of the light in class 12th also. But now we are going to discuss about what is light. Light is that source of energy which enables us to see anything. The room in which you are sitting or the place in which you are sitting, you are able to see the every surroundings just because there is the presence of the light. If light is not present, we are not able to see anything. Just I am giving the example that if the room will be dark, then everything is invisible. I am not visible because there is no light. Now hope my colleague will open the light and I am again visible due to the presence of the light. So, light allows everything to see. Light helps you to see everything. Light enables your eye to see everything. But my dear students, can you able to see light? I am just asking that light is allowed to see you everything, but are you able to see the light? Means hope I am just using the laser light here, and this is the red laser light. This is the light, this is the source of the light, and this is the point where it is going. Okay, but the fact this is the source and this is the light point of interaction, point of intersection, and the light is going through this path. Are you able to see the path? Hope you will not, and you will have to find the reason for it. And we will go through this topic in the scattering of the light today. But before discussing about that, we are going to understand about the light and the phenomena which discuss different topic or different processes in the case of the light, that are reflection and refraction. You have better idea of reflection. But reflection is what? You are able to see me because the light coming from the source is striking on my face, my body parts, and it is get reflected and it goes to your eye, and that's why you are able to see. Now, I am just asking that, have you seen the reflection through a mirror? I hope you will see it. This is the mirror, my friends, my dear students. This is the mirror, and I am using the mirror as a source of the reflection, and this is the laser light. I am focusing the light on the mirror. I am focusing the light on the mirror, but the light will be seen here in the board, somewhere on the board. Okay, let's see it. Are you able to see it? That is the light. Hope you are able to see it. I am focusing the light on the mirror. The light is visible there. That is due to the reflection. But in this case, even the room is dark, you are not able to see the path. Are you able to see it? The path is not visible. The reflection is visible. Okay. Now, I will suggest my colleague to open the light, and I am again visible due to the presence of the light. This is called reflection. Even in case of reflection, you are not able to see the path. Now, we are going to the refraction, and we will find what is refraction is. Hope you have got the idea related to the refraction in the chapter light. And that refraction is that phenomena in which the light passes through one medium to another, different mediums, and the path of the light gets changed. the path of the light gets changed. The point is, the path of the light gets changed, but the path will not be visible again. I am going to show you. The path will be not visible again. You are not going to see the path. Okay? Then try it. Now I am focusing this laser light on upward direction, but the light which is visible there is in the downward direction. Okay? They are in the downward direction. So the light, the diagram may be like this. I am using the red pen. The diagram may be like this. I am focusing the light in this direction, but the light which goes, it will find in this direction. Hence the path of the light is changed. The light has to go this direction, but the light has chosen this direction to go through it. And this is called refraction. And even we are not able, although we have drawn the path, but we have not seen the path of the light. This is miracle that we are not going to see the path of the light, but we are drawing the path of the light, and that are known as rays. So dear students, we are going to find out that how we have drawn this path. By magic, or is there any physics related to it? I am just going to clarify. There is physics related to it. You can see the path, and that is able, that path is visible just due to the scattering of light. I am just going to discuss about the scattering. And scattering of light. This is also known as the Tyndall effect. This is also known as Tyndall effect. This is known as Tyndall. Tyndall is the name of scientist. He shows that when the light ray passes through the colloidal solution, the solution in which there is a dispersed phase and the dispersed medium, and the light is visible to us. That is due to the scattering of light. The light is scattered in all directions. Hope I have used the torch there and the light is going there. The light is only visible to us when it comes to our eye. That I am using the path, this path. If light is visible to you, that means the light has gone through that path also. And if the light is visible to this part also, the light has gone through this part also. Upward direction, downward direction. That means if the light is visible from all the part, although the light is going in a straight line, if light is going in a straight line and visible to all the part, that means the light is scattered in the different directions. I am just going to show you the scattering of light with the experiment. But before that, we are going to discuss about the Tyndall effect. The Tyndall effect is the scattering of light, and that causes the light visible. That causes light visible. Okay, that causes light visible. And when you are able to see the light, you are able to see the path of the light. Hope you will get it by an experiment. A simple experiment is there. I will show you. And this is the scattering of light that causes the light visible. This is known as the Tyndall effect. And my dear student, the scattering is different for the different. Although the white light has the 7 different colors, and the 7 different colors have the different wavelengths. I hope you will get it. The light has the 7 different colors. The white light has 7 different colors, and the 7 different colors are red, orange, yellow, green, red, orange, yellow, green, blue, indigo, and the violet. The 7 colors are there. And my dear student, the light, although light travel in a straight line, the linear equations is there, but light can be observed as a wave also. You will study in the different videos or in the different classes also. The higher classes, this is for the plus 10th video, and you can go in the higher classes, you can find out that the light can be seen as a wave also. And from there you will find that the red color has the maximum wavelength. It has the maximum wavelength. And the violet has the minimum wavelength. Okay. And the wavelength decreases in this direction. It decreases. I will use the different marker. It will decreases. Okay, it decreases. Red to orange to yellow to green to blue to indigo to violet. And one of the scientists who discussed that the scattering depends on different factors. It depends on the size of the colloidal particles. You must note it that the scattering depends on the size of the colloidal particle. The size ranges from some nanometer to some nanometer, 1 nanometer to less than 100 nanometer. That will be a range. Okay, that may be a range. Some range will be there, and the size. If the size varies, the scattering will also vary. We are living on Earth, and our Earth contains our Earth atmosphere contains some colloidal particles also, and we are able to see the scattering there also. So it decreases, and one of the scientists, that is Rayleigh, according to Rayleigh scattering, he shows that scattering of any color is inversely proportional to the fourth power of the wavelength. This is just the equation, you do not have to derive it. Means if the wavelength is more, the light is scattered least, and if the wavelength is least, the light is scattered more. That means if the red color is passing through some device, it will scatter least. And scattered least means it will travel to a longer distance, because the scattering causes the light broader and broader and broader and broader, and if it scatters much more amount, then the light is not visible to us. And light is only visible to us due to scattering. So we need the scattering such that the light can comes to us. By scatter, the light can reach us to our eye also. Scattering is necessary, but the scattered light must visit to our eye so that we are able to see it. Okay, so then you have to note it down that the scattering is inversely proportional to the fourth power of the wavelength. Means if the wavelength is high, the scattering of the light will decrease, will be less, will be low. Okay, and if the wavelength is more, then the light will be scattered least, and if the wavelength is less, then the light will be scattered more. Okay, generally that's why we are not able to see the violet and indigo color anywhere on the earth, because the colloidal particles are that size which can what you may say scatter the indigo and violet in the large amount. That's why they are not visible to us anywhere. I am just giving the experiment to show the light can be visible to us. Okay, just scattering of light. A simple experiment is there. This is the colloidal solution I am using. Okay, and this is the laser light. I have passed different light, that is glass slab also. Again, you are not able to see the path, my dear students. You are not able to see the path. You can see the different 2 points, but you are not able to see the path. But now I am going to show you that you can able to see the path, and that can be done by an experiment that is known as scattering of light. Okay, it will be better that it will be a dark room. So just see that. Just see that. You are able to see the path. Are you? Are you able to see the different path? The light is scattered much more in the solution, but from the point of intersection, you are able to see some path. That just see it. You are able to see the path. I hope you are able to see the path. Okay? And the scattering of light also. The solution contains the red color. That is due to the scattering. Okay? I hope my colleague will open the light. And again you are able to see the path. Hope you are seeing it. Hope you are seeing it. You are able to see the path also. Okay? The true solution generally do not show scattering. But suspension and colloidal solution has that colloidal particle size, that the size of that particles can able to scatter light. They have the ability to scatter light, and that is scattering that causes The light is visible to you, that I am focusing the light in this direction, but light is visible to you, my dear students, and that's the reason that light which is going in this direction is also going in that direction. That means the light is scattered. Now we have some general phenomena in our scattering of light which we are able to see in our day-to-day life, that are, I am rubbing it, the natural phenomena which we are able to see are, some of the examples are the blue color of sky, the blue color of sky, this is the natural phenomena. Our earth atmosphere contains that colloidal particles which scattered the shorter wavelength in a visible amount that comes to our eye. So blue color has that wavelength which is comparable to the size of the colloidal particles in our atmosphere. So blue color is scattered in that amount that color comes to our eye from the scattered part, and we are able to see the blue color, and the sky is blue. It is just because of the scattering of light. And in the morning and in the sunset, during the time of sunset and during the time of sunrise, the sky generally appears to be reddish orange color, and that is due to the red color has the maximum wavelength, and during the sunrise and sunset, the light has to travel the maximum distance, and the red color is due to the scattering of light during sunrise and sunset. Sunrise and sunset. So, if the light has to travel the maximum distance, all the color are scattered much more. But due to the maximum wavelength of the red color, it is scattered least and able to comes to our eye. That's why we are able to see the red color. Red color having the maximum wavelength. It is scattered the least, and this is the only color which reaches to our eye during sunrise and sunset. And that's why we are able to see the red color of the sky during sunrise and sunset. Hope you will understand about the scattering of light, and that is the scattering of light that allow you to see the light. Okay? Now the light is only visible to us, not only visible to us, we are also able to see the different part using the light. Now after completing the scattering of light, you can say that you can see light, and by using light you can see anything. Okay? Now some homework is there. Some homework are there, some questions are there. Okay, the question says, first question, very simple, that is, what is Tyndall effect? What is Tyndall effect? The second question is, it is also easy, I have discussed it, but discuss something different, and I am asking you something different, that why do we use red color in danger signal. Generally we see that red color is a sign of danger. Why? Again we have discussed that why sky is blue. Why is sky blue? This is also discussed, and you can write the answer by yourself. And next question is, the fourth one is, that is the last homework. My dear students, the astronaut, if you have seen the different videos related to the atmospheres and space, the astronaut are not able to see the sky as a blue. So why sky is black? Sky is black for an astronaut. Okay? So that's all from my part. Okay? Hope your day will be good. Tata, bye bye.